Assalamualaikum and welcome to our project Numerical Analysis of Non-Linear Root Finding using secant method, exponential method and 3-point secant method. Our team members are first, Farah Atika binti Muhammad Azra'i, second, Siti Najwa binti Izaham, third, Nurul Nabila binti Rosli and our supervisor, Dr. Azmi binti Syahari. The value of root finding research is increasingly recognized in the literature. It can be found in a variety of applications in physics, chemistry, bioscience, engineering and other fields. In fact, determining any unknown that appears subtly in scientific or engineering formula leads to root finding problem. A root finding issue is one in which the goal is to locate the root of equation fs equal to 0. Nonlinear equation usually can be solved by iterative methods. There are many well-known existing methods in nonlinear equations such as the bisection method, Newton-Raphson method and secant method. However, what makes different between this method is the rate of conversion to the root. Problem statement. The secant method is one of the common iterative methods used in nonlinear root finding problems, but it does not have cognitive conversion if the initial values are used too far from the root and tend to have many iterations. Hence, two improvised secant methods have been studied, which are exponential method and 3-point secant method. Second, the nonlinear equation also emerged in science, engineering and computing, but they are difficult to solve. Therefore, the objective for this project are first, to determine the root of the function and number of iterations required between the secant method, exponential method and 3-point secant method. Second, to solve the nonlinear equation of the photovoltaic Febby cell.
To achieve the objectives of this study, graphical user interface GUI were developed to offer visual representation of the desired results. All the data for the comparison of the secant method, exponential method and 3-point secant method were collected from GUI simulation. Here's how it will work.
This is coding GUI for test functions and this is coding for previous model. The user need to run the MATLAB and the GUI will be appeared. First, we need to enter any nonlinear function. Let's say x power of 3 plus 4 x squared minus 10. Next, we need to enter any initial points randomly. We set the tolerance and we may click any method. And this is the graph and the results. We may click next button and the GUI for our previous model will be appeared. First, we need to state parameters value and the initial points randomly. We set the tolerance and we may click any method. And the result number of iterations and root will be appeared. We may click clear button to change initial points.
Comparison of number of iteration for numerical test function and photovoltaic cell. These are the table of comparison for number of iteration for numerical test function and PV cell model. As conclusion, 3-point secant method converge faster to the every respective root of function than secant method and exponential method, since 3-point secant method need the least number of iteration. However, for PV cell, 3-point secant method need a similar range of iteration with secant method. Thus, 3-point secant method clarified as the best method among 3 methods.
Originality. A GUI is a type of visual enhanced interface that allows users to interact with an electronic device through use of computer-generated items, such as screen displays, icons, and visual images. Uniqueness of GUI. Firstly, made up of necessary elements that are logical and concise. Secondly, create clear and concise labels for buttons and actions. Thirdly, allow users to perform tasks with speed and ease. In other words, it operates with efficiency.
Commercial potential. The GUI developed are easily implemented software that can be used for any computer to help in users, especially students solving root finding problems in numerical analysis.
There are some benefits that we may gain from this project. Firstly, the 3-point secant method recognized as the most efficient iterative method. Secondly, the results are more organized and attractive when GUI was used, since GUI as a visual representation. Finally, it makes it easier to record the results.